Okay, so today we'll look at still solving two-step equations. Some will be in multiple steps, but it's with distributing and combining like terms. Distributing are the rainbows. You had parentheses and you drew rainbows, some of you, in 7th grade, and you combined like terms in 7th grade. Now you're going to distribute and solve and combine like terms and solve. All right, so the distributive property is to multiply a sum by a number. You multiply each addend, remember that word addend, by the number outside the parentheses. And there's an example, because that's a lot of words, and some people don't understand the words, so there's the example, right? Rainbows, see them? Okay, so that just means you take the number outside the parentheses, and you have to multiply it by everything inside the parentheses, including negatives and stuff, okay? That should be reviewed from last year, so I don't think we have to spend an hour on that. You guys can abbreviate that as much as you want. Okay, so the sum is the x plus 3, right? The addends are x and 3, and then the number on the outside is the 5. That's what all those terms refer to. So when you multiply with the rainbows, you get 5x, and then the 5 times 3 is 15. What happens to a lot of people is they're good with the first term, but they're not good with the last term. So they'll do 5x plus 3 there, or 5x plus 5. They forget to multiply. So I always say a real good strategy here is to actually draw those little rainbows. Okay? So if you didn't learn that last year, or I don't know, I think you did, you just forgot. But I would say always draw them. Like I still draw them, and I'm, 102. So I think you should just keep drawing them. I really do. Okay, well, 102 minus 67. All right? So, rainbows. Okay. Oh, I have to cover up some of this because I put some shortcuts. And I don't want you to see yet. Okay. So, example 1. We have a negative 3 on the outside. And we have an x plus 3 equals 12. So you can see that negative carries through, right? You see how that went through? So it becomes a negative 3x minus 9. Some people put plus 9 there and they're wrong. Then you get the whole problem wrong and you go back to check your answer and you're like, what did I do? So draw rainbows. There to there. Okay? Then from here we know what to do, right? We know that we add the 9 and divide by negative 3. Do you remember this? We've been doing this, right? So we get negative 7. We add 9, divide by negative 3, we get a negative 7. Are we okay with that? That we've been doing. But there's a super awesome shortcut. Does anyone know what the super awesome shortcut is here? Do we think there's a faster way to do this problem? Or do you just want to draw rainbows all day? You want to draw rainbows? Does anyone see it though? Does anyone see like a number that could go into another number maybe? Who sees it? Max, do you see it? 3 can go into 12. Wow, Max, you're smart. Look at that. Here's a little shortcut. If I take the negative 3 and I divide that over into the 12, I'm going to get negative 4, right? 12 divided by negative 3 is negative 4. And then all I have left is the x plus 3, and then I just subtract it. Is that a little faster than multiplying and then undoing what we just did? Seems a little faster. I'll show you again. So here's the negative 3, right? Negative 3 goes into 12, negative 4 times. So then I just write x plus 3 right here, x plus 3. Subtract 3 from both sides and I get negative 7. Is that what I got here? There you go. Want to see another shortcut? Yes. I think you do. Question? All right, here's another one. If you don't believe me, it works every time. Okay, here's another one, here's another one. So, let's look at this. 4 times 2x plus 4 times 7. So here's the rainbows. So that would be 4 times 2 is 8, right? So then we just write 8x. 4 times 7 is 28. Now we have to subtract 28 and divide by 8. Subtract the 28 first. Divide by the 8. And x should equal 10. Can I use the shortcut here? Does 4 go into 108? Yes. So I'm going to show you the shortcut. See here, we multiplied and then we subtracted and then we divided. Seems like a lot of work. Why don't we just divide 4 into 108? Let's do that. So if you divide 4 into 108, you get 27. And then it's the 2x plus 7 equals 27. So we subtract 7 and divide by 2. Look at that. Wow, I got the same answer. That is a great trick. Should we do another one? Some people aren't convinced still, huh? Alright, we'll do another one. How about this one? Will it work on this one? Will that trick work? Raise your hand if you think it will work. Raise your hand if you're like, nope, it won't work. Okay, those who said it won't work, tell me why. Why? 3 doesn't go into 14, but what else why? There's something else that's different about this problem. Julianne? Yeah, there's a plus 5. But what if I subtract 5 first, right? So if I subtract 5, I get a 9, right? And if I distribute, I could still solve it this way, right? Here's how you solve it the long way. So if I subtract 5, I get 9. And then 3 times 2x is 6x. And 3 times negative 1 is negative 3. Right? So I should get something like 6x equals 12. And then I have 2. And I'll show you what happens. You can use the shortcut, just not right off the bat. First you have to subtract the 5, okay? I'll show you. So if I subtract 5, I get 9. And then I can divide by the 3, because 3 does go into 9 evenly. And there we are. 2x minus 1 equals 3. Add the 1, 2x equals 4. Divide by 2, x equals 2, and we get the same answer. So this one's a little bit longer. You still have to subtract 5 first. But this one I did distributing, combining like terms, and then adding and dividing and reducing and all that stuff. Here, all I did was I subtracted 5 and then divided by 3 and then solved that way. So what happens, you guys, is if you do it the long way, you're going to get bigger numbers, right? Because you're multiplying. If you do it the shortcut way, you're automatically going to have smaller numbers to work with. I don't know about you guys, but I like working with smaller numbers, don't you? Yeah? I think it's better. Okay, want to see one more just so I can prove that it works? Yeah, one more. Just 4 examples. Okay, here's one more. This one right here has a fraction. I know you love fractions and everything. Do you think there's a shortcut with the fraction? Who says no? Who says yes? Who has no idea? Okay, the yeses are right. There's a shortcut. Should I divide by 2 or multiply by 2? Should I divide or should I multiply by 2? Oh, you're so right. You should multiply. Right? Because multiplying is the opposite, and that would be that reciprocal multiplicative inverse thing we've been doing. So all I have to do is 2 times 8. That would be my shortcut. So I'm going to show you both ways. I'll show you the long way and I'll show you the shortcut way, and you decide what you want to write down. Here's the long way. I have to multiply that fraction, and if you don't remember how to multiply fractions, that's going to be a problem, isn't it? So half of x is half x. Half of -4 is -2. And then 1/2 x equals 10, x equals 20. That looks ugly. Here's the shortcut way. I put a box around it so you can remember. It's called clearing the fraction. That's what we say in math, right? Clearing the fraction. So we just multiply by 2. X minus 4 equals 16. Add 4 and you get 20. Wasn't that a lot faster? Works every time. Every time. Cross multiply. Any questions on that one? What I did with the fraction? We're okay? Yeah? This one? 2 times 8. Cross multiply. Good question. It's basically the same as flipping it over. Multiply by the reciprocal. That whole first day we did all those multiplicative inverse problems where we had to keep flipping and multiplying, remember? Flip the fraction, multiply, we always got 1 on one side, right? Same thing. Alright. So that's distributing, but we have to do some combining like terms. Alright, so like terms. Like terms are terms that contain the same variable to the same powers. Here are some examples. Same variable to the same power. You could have x squared, x cubed, but we're not going to do those quite yet. We did a lot of this in 7th grade as well. Mr. Martin probably brought out some blocks, some colored blocks. Remember that? They were like blue, the bigger sticks and blocks, remember? And then he said these are the same terms and you got to combine them together. Did Mr. O'Hara do that too? Yeah. Yeah? Okay. I did that too. I don't know if Miss Garner did she? No. There's these little, they're like a stick, they're algebra tiles. And then there's blue ones and I think red ones.
Wait, are these little?
Yeah, little tiny blocks.
Yeah. Oh,
yeah, and you had to like put them, match them, and then combine them, count up how many little blue things you had and how many little red things, right?
Yeah.
And they represented X or Y maybe. Did you guys do that? Yeah. Good. So that's ingrained in your brain? I hope so. All right, this is the easy stuff, right? You know it's going to get more challenging. Just like the distributing did. So here I have an x plus x, so that's 2 x's. And then if I have a negative 3y and a positive y, I have negative 2 y's. Do you remember that? With the negatives and all that? Sorta. Is anyone a little confused on the second one? The negative 3y plus y? We're okay? We know there's an imaginary 1 in front of the second y. So negative 3 plus 1 is negative 2. Okay. All right, because that's a whole other day, right? So here's what it looks like in 8th grade math. And I always circle the like terms because that helps me find them right away. So here I have 16x plus 42 minus 13x equals 24. So now we're combining and solving. I circled my like terms. Do you do this? You should do this. Just like when I told you to draw rainbows, you should circle your like terms. If you circle your like terms, you're going to get an A. Plus, 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 I bet. You will. So what's 16x minus 13x, guys? 3x, good. So we have 3x plus 42 equals 24. So far, so good? Then what do? Subtract the 42, which you guys hate because you get a negative. But you subtract it, you get negative 18. You have to divide by 3, and then you get negative 6. Is there a shortcut? No. Too bad. No shortcuts on these. Any questions on that one? It's okay? All right. That means your 7th grade teachers did a good job. Let's see. Here's another one for you. Circled the like terms again. 13x minus 19x. So what's 13 minus 19? Negative 6, right? So negative 6x plus 12 equals negative 24. Then what do? Subtract 12. Good. But when we subtract two negatives, it's like adding them, keeping them negative, right? So we should get negative 36, negative 6x over here, divide, and get a positive 6 because those negatives will go away. Cancel each other out. Any questions on that one? It's okay? Thumbs up? Thumb sideways? Thumbs down? Just down because you're tired, right? Okay. Last example of combining like terms. I circled my like terms, which are negative 17x and negative 8x. What's negative 17 and negative 8? Negative 25, good. Negative 25x minus 22 equals 128. Now what? Add 22, good. Add 22, we get negative 25x equals 150. Divide, and you get negative 6. Oh, I put one more example. Should we do it?
Yes.
I'll show it to you if you want to. If you want to have one more, you can write it down. If you're good, you don't need to write it down. But it's there for you if you want to write it down. All right? So 4 examples. Now you're going to get a lot of practice today, so if you're still a little confused, that's okay. That's why we have practice. Okay, but you will practice this stuff. It doesn't come naturally, it doesn't come easy. Bryce?
Why do all of them equal 6?
That was weird.
Last one equals 2.
The last one equals 2, but these... I don't know.
Yeah, last one doesn't count.
That's weird, though. Yeah.
They all equal
Mm-hmm. Okay, there's one more little bit on the next page that's like the most important thing ever. I'm going to make you smarter right now. Are you ready? Here we go. What happens when I have to put those two together? Combining and distributing. Oh. Distributing?
Yeah.
Oh. Okay, here's what happens. And this you will do today and on your test. So we're going to put both of them together. Here's an example. All right. Last page of notes here. I know it's a lot, but we're almost finished. This is what happens when we put both of them together. When we have distributing and then combining like terms. No shortcuts here, guys. Sorry. All right, so first distribute. Okay, we have this negative 5 times 3x thing. That's going to be negative 15x. And then we have a negative 5 times 10. See that? So here's what it looks like. I'm going to slow this down because this is where I lose a lot of you. So that's the 4x minus the 15x minus 50. Anyone lost yet? Good. Next step. Combine like terms. What's 4x minus 15x? Negative 11x minus 50 equals 126. Now, I know once you get here, you're okay, right?
Yeah.
It's just the journey from here to here that you might get lost. Okay? So we add 50 and then divide by negative 11. Add 50, divide by negative 11, and we get negative 16. Don't forget the negative. All right, you ready? One more. See if you can handle it. I think you can. I think you can handle it. Here we go. Example 2. 7x minus 2 times the 3 plus 4x equals 19. Again, distribute that negative 2. So we should get 7x minus 6 minus 8x equals 19. Combine like terms. What's 7 minus 8? I should circle those, huh? I didn't circle them last time. So it's negative 1? Negative 1x. Good. And we don't need to put the 1, so we could just write it as negative x. Right? If you put negative 1x, it's not wrong, but you don't need the 1. So negative x minus 6 equals 19. Everyone follow me so far here to this spot? Good. Add 6. Add 6. So what should my answer be when I add 6? Okay, and what's the answer for x? Who says it's 25? Who says it's negative 25? Aha. Tricky, tricky. The negative's going to go to the other side, right? Because we have to divide that negative out. We're not solving for negative x, we're solving for x. I'll put a sad face, but I'll put 2. No shortcuts. Bum, bum, bum. Right? Do you think you can do this on your own? Who thinks they can? Raise your hand. Who's like, no way? Yeah, I think we should do some of these together. All right.